Okay, the actual problem can be found in PDF format under handouts and links. But here's the video for the solution for the problem that you had to do in class on Wednesday, April 8th. The force is equal to the spring constant times the length of elongation. The length of elongation was 12 centimeters, and the object was given to you as a mass of 60 grams. So this means then that the force is actually going to be equal to 60 grams times the acceleration, which is 980, to keep it within centimeters per second squared, to keep the units right. And this was 58,800. Therefore, 58,800 divided by 12 is equal to 4,900, and that is equal to K. So therefore, omega squared, since omega squared is K over M, omega squared is going to be 4,900 divided by 60, which reduces to 245 over 3. That's omega squared. 2 lambda is equal to beta, the damping constant, divided by the mass, which is the damping constant was 360, the mass is 60, and this gives you 6, which means lambda is equal, lambda cube, lambda is equal to 3. Okay, so now we need to check how damp this is. So we need to look at lambda squared minus omega squared. Lambda squared minus omega squared is going to be 9 minus 245 over 3. Remember, remember that this 245 over 3 here is omega squared. So you don't square this. People mess that up. So make sure you don't square this. This is obviously less than 0. So this is going to be an underdamped situation. And then you use the formula for underdamped. So we need to find out what the square root is of omega squared minus lambda squared, which is the square root of 245 over 3 minus 9, which if you do this work, you get the square root of 218 over 3. So therefore, x of t, if you use the formula for underdamping, is e to the negative lambda. Lambda is 3, so e to the negative 3t times c1 cosine of square root of 218 over 3t plus c2 sine of the square root of 218 over 3t. And that's the general formula. Now, the other information, of course, is that it was released at equilibrium, so x sub 0 is 0, with a downward velocity of 4 centimeters per second. So that the units were correct there. So x prime of 0 is equal to 4. I'm going to clear this up and start a second page here. Okay, so this means then that since x sub 0 is equal to 0, this means that 0 is equal to 1 times c1 times the cosine of square root of 218 over 3 times 0 is 1 plus c2 times 0. This means that c1 is equal to 0. So x of t, therefore, is equal to e to the negative 3t times c2 sine of the square root of 218 over 3t. Okay, now we're going to take the derivative of this, and just to give you my plan here, product rule, I'm going to let that one be f and this one be g is how I'm going to do this. So I will do g f prime, so this is going to be negative 3e to the negative 3t times c2 sine of the square root of 218 over 3t. And then plus, I'm going to go down to the next level here, e to the negative 3t times the derivative of this. We have to use a little chain rule here, so this is going to be square root of 218 over 3 c2 cosine of the square root of 218 over 3t. And that's the product rule. So since x prime of 0 is equal to 4, then 4 is equal to, all right, now let's start putting 0 in, negative 3 times 1 times c2 times 0 plus 1 times the square root of 218 over, I guess, square root of 3 times c2 times 1, which means 4 is equal to the square root of 218 over the square root of 3ct, which means ct is equal to 4 root 3 over the square root of 218, and this gives us our final answer. X of t is equal to e to the negative 3t times 4 root 3 over root 218 times the sine of the square root of 218 over 3t, and that's the final solution. Thank you very much.